CS building, or just about Might not have been her at that point. Could have been something else, probably somebody else. I think she was upstairs in the lab still.
Yeah, 'cause I remember she was over by us. Something.
Yeah, she was, she was associate chair.
Yes, I think new office. Yeah, it's hard to...
Carla said she was coming. I haven't been able to find Shayna.
Okay.
I know Sheena's around,
Yeah.
but she was helping Monday.
Too busy, yeah. I'll start at 10 after.
What? I know Karen's like, I want like your ear. I want to like, But I like the class. I like how you give.
Can we just say late?
Now someone, what professor, I don't know what it was, and the student was like 108. Well, I had a appointment at 1 o'clock, and he'll be there just probably about 3 minutes. If we do a Michigan time, what's a Michigan
If
time?
you're
I'm
not
like,
early,
well, I
you're
don't know if
late.
that's
It
exactly
is
what's
a
going
wonderful
on.
phrase.
But he's not there in 5 minutes. Come back and see me, and
All right.
he never came back. So.
Another one.
But I do like.
Yeah. There's 2 of them today, right? 2 of those visitor folks.
Yeah.
Yeah.
And there's a safety committee meeting at 800, so I have to take them down.
Oh, man.
Copy them from there.
Amy? Oh, yeah, you thought about
Jamie's on vacation until Thursday, and then I leave Friday morning.
Oh, man.
Where are you going?
Georgia for the weekend.
Yay.
I know.
I had a softball mom going to Georgia on Friday morning too.
Really?
It's no block. Lots of teachers or something. What I do like, Leland, about the examples is, if I've learned anything, it's about just being so ever so careful with typing in things.
Right.
And I like it that you give a nice big blob to type, because like, as I'm typing it in, it makes me feel all smart. Like, I know what I'm doing, even though I
know what you
have
mean,
to,
yeah.
but to feel, it makes you feel
Yeah, like you're doing
the work a
something
little
real.
bit, or it makes you feel the code, or feel what's right and wrong, and, I've probably forgotten what all the wrongs are, but anyways, it helps,
Well,
makes the awareness of what you gotta watch out for.
That's what today's review was all about. We had 2 weeks off, and the last thing we did was functions, which I think was somewhat challenging. So we're going to go over everything.
What day are we actually on, 10 or 9?
9. Depending on how you count. We had 2 day ones. We had 2 day ones, so I think we had 2 day 5.
There's 1 or 2 people showed up, and
Yeah,
some
yeah,
hadn't,
exactly.
and
Yeah.
I was thinking, I can get to work so much quicker with all the winter weather.
I know.
I'm like,
I know, isn't
it's
it?
really kind of amazing. I
But
can
now
get to work about the same time
But
every
now
day.
it's potholes. Oh boy.
Yeah, now it's like
Oh
you
boy.
really do.
And
I'm trying to
Mr.
tell my
Wool be the
16-year-old
man
daughter
who tries to
avoid
repair his own
potholes.
pothole. Did you see that? Go to
What?
Main Street, some homeowner on Main Street patched his own pothole in
Yeah.
front of his house, and he
Yeah.
got in big trouble for it.
Of course.
Wow, shame on him.
Because it probably wasn't, because they'll end up
Wasn't up to
tearing
code.
it out, right, because it's not the right mix. or-
Yeah, of course.
But it's avoiding some
Yeah,
big,
exactly.
bad,
Yeah,
more
except you know what?
ugliness.
The city can't be sued for that, because you're supposed to be in control of your car. The insurance company won't pay for it, because you're supposed to be in control of your car. So,
It's ridiculous.
it is.
It is ridiculous.
Somebody
He's like a
needs to
good
pay.
citizen trying
Yeah.
to do
Yeah,
something
it's-
good, and
It's
he's
the
kind of
usual,
like,
you
Yeah.
push the costs on everybody else, and you
Right.
don't give a crap.
Right. Yep.
you said day 9.
You're evil.
Yeah.
9, yeah.
Day 9, yeah. All right, I think we're going to
That's
start.
not fair.
Okay, today we're going to do a review. And so we're going to start from the beginning, how to use Linux, declarations, printing and reading, ifs and whiles, and all the way up to functions from 2 weeks ago. So perhaps you remember all this, perhaps you don't. So with Linux, ls is a command to list the contents of wherever the heck you happen to be, folder, directory, whatever you want to call it. cd changes the directory to another one, and you use double dot to go up. You remember that, and you can, and even with ls, you can use the double dot to list stuff in other directories if you want to. cp, copying a file, usually it's from and to. From and to can have these double dots in them too if you want, so you can get stuff from day 2 and copy it to day 6 or whatever. rm, deleting a file, which probably haven't done. pwd tells you where the heck you are. Gives you the directory name in case you're lost, which is easy enough to do. gcc, you use a million times. That's how you compile your program. Goes from source code .c file to an executable, which is whatever without the .c. Emacs, editing a file, and make a directory, or a folder. So, real quick, then how to develop a program. First you got to log in, then you create your command line. Then you go to wherever the directory is that you want to do all your stuff, using perhaps cd. Edit the file with Emacs, compile it to GCC, run it, and repeat until it works.
Repeat and sanitary.
It's like washing your hair, right? Repeat until done.
Hopefully it's only once per cycle.
It never is. I mean, let me tell you, I've been doing this for 35 years. I never get a program to compile and run right the first time. Never.
Even knowing all the little
Even if it's
mix
just a
and
little
matches
teeny
you
little
do.
thing. It's not going to happen. At least have a typo somewhere. Okay, so here's how you compile. GCC, -o is a command line switch saying the next thing that I say is the output file name, and then you give it the input file. And then to run it, / the executable. Declaring variables. First you have to declare all variables, right? You can't have a variable in your program if you didn't declare it. It'll just yell. Why is that? Because the variables are interpreted differently. All those bits. For characters, there's only 1 byte, 8 bits worth of information. For real numbers, there's 8 bytes. For integers, there's 4 bytes. So all that encoding matters. So the compiler needs to know how to decode it, or it's not going to do anything. So you've got to declare it with one of these things. Int, double, R, whatever you want to call it. And you can do a whole bunch at once if you want. Of course, semicolons are favorite. Practically everything, but not quite everything, ends with a semicolon. And so assigning stuff. And remember, this is variable assignment. This is not mathematical equals. I will emphasize that all the time. You're probably sick of it by now. So we're assigning the value 1 to the variable b. Assigning the value 1.5 to c. Assigning the value d to the variable t. So there's no equality involved. Simple math, addition, subtraction, multiplication is kind of strange with a star, and division. And then parentheses you can use to make complicated expressions if you need to. So the stuff in parentheses will happen first.
I did that on my 6th grade daughter's homework.
Yeah.
I used this twice in one day. What do you know? What a small world. I told you about the little
Hey, Carla.
Chelsea school.
I got caught up.
I understand.
I told her, I said, this really does matter, because Mom is using it in the real world.
Yeah.
Pay attention.
Yeah, definitely. Okay, so the if statement. Very often you need to do something different depending on the equality or inequality of some variables. So the if statement is there so that you can use the test, whatever it happens to be, say A is less than B in this case, and then use these curly braces to enclose some code that you want to do just when that is true. And there's a bunch of others, less than, greater than. Equals is now equals because equals is a sign that something you don't want to get too confused. So equals means logical equal, and there's less than equal, greater than equal. And if you need to do more than one comparison.
Wait, I have a question.
Yes.
How come it's not less than equals equals or greater than equals equals?
Because there is no less than or equal for it to get confused with, right? This already exists.
Right.
This doesn't
Okay.
already exist, so it
Okay.
doesn't need another
All
equal.
right. Good.
Yeah, exactly. It's all just a very dumb program is reading through our program to figure it out. And so we want to make things simple for it. Because it's going to generate all this code for us. And it needs to understand what we mean. And to make it easy to write it, because they're writing it in C as well, that makes it easy for us to figure out that's what you mean instead of finding. So, if we've got more than one of these we want to do at one time, we can combine them with ands and ors. So, and instead of using the word, I don't know why they did it, but they decided let's use a double ampersand.
Where would it fall? Would it fall into separate parentheses, or would it fall all into?
So, for example, let's say you wanted to figure out what tax bracket you're in. That may sound familiar. And you've got you've got your salary, and you want to see if it's greater than or equal to 50, and if your salary is less than, say, 60. So that's the kind of thing that you would do. So this is one of them, this is the other one of them, and you're combining them with the and.
Okay.
And that's a common occurrence, as well as our ors. So we use parentheses to enclose the logical condition, that's this part here. And we use these curly braces to enclose the code that we want to do, which could be one or more lines, actually. But that would be strange. So one or more is the usual. So that's if. Here's printf. Printf is how we display stuff to the user. And so this has a string from here to here, this double quoted thing, that's a string. And then this is a variable that we want to somehow place into that string. So this %f here tells this command where to put that value in this string when it prints it. Is that convoluted enough?
Basically, every time you use printf, you're going to have %f.
And you don't actually need to have a variable. You can just print a string if you want, and you don't need to print a variable, and you don't have to have a %f, you don't have to have a C, you don't have to have anything. You can just print a string. Sometimes I just print \n, and that's it, just to have a new line somewhere. So you can have one of these control characters in here, or several if you want, but you don't have to have any. But you do have to have a string, otherwise you're not printing it. So you have to have a string of something that you're printing. And it usually ends with this \n, so you have a new line at the end. But even that you don't have to do. Which is why you have to do it explicitly, because sometimes you don't want to do it. Fortran, for example, you do a print, and this is implicit, it always does this, which is actually kind of a pain when you don't want it. So anyway, they make it so that you have to say that you want it in order to give you flexibility in what to print. So, okay, so there's %f for, in this case, a floating point or real number. But there's %c for printing characters, and there's %d for printing integers. And you have to know what the heck you're doing. you use the wrong one for the wrong thing, and you'll probably get garbage. Because compilers just does what you tell it to do. So telling it to print a real number with a %C, and it may give you a compiler, or it may just print garbage, I can't remember which. So that's very, very important, that control character matches the type of whatever variable it is. So you don't have to have the comma C here. You can just print a string if you want. But if you want, you can also have a comma variable, another comma, another variable, as many variables as you feel like printing. But have one of these for every variable that you want to print so that it makes sense.
And if I wanted it to print CAT, it's still just CAT. So the %F is saying you're going to print something. The \n is saying I want you to print it on the next line. And the comma is separating the string from what you want printed.
Right.
But how would you either, what would it look like if you wanted a bunch of characters printed on the same line, or you wanted a bunch of characters printed on separate lines?
Okay. So, a bunch of characters printed on the same line. Let's say you had spaces between them. Just so that you know what's going on. And then let's say your character, the variable name, let's say the C1, C2, C3. So, that's what you would do. So, for each one of those, you've got one of these.
Okay.
And if you want to separate lines, here's where it actually gets quite easy. You just put a \n. And now we've printed 3 lines with one printf statement.
Okay.
It's nice
Okay.
when you need it.
With that.
Yeah, definitely. Any other questions, ideas, examples? Okay. So that was printf, getting the value of a variable to print to the human. In the next one, scanf, you've got the value of a variable that you want to suck into the program. So it's the opposite direction. And why they came up with scanf and whatever. So it's very similar to printf. There's a string that tells it what to do, and then there's a list of variables that these things get read into. It's a little different in that there's this and in front of each of the variable names, which we have yet to explain why. Just remember it for now. And we don't tend to use the \n on scanf, pretty much because we're not printing for a human to read it, right? We're just reading something. And when you read, the \n is just kind of implicitly there, no big deal. So you don't need to tell it there's a \n there. And sometimes \n that might be there on the line that you're reading is really just read like any other character. It doesn't really care. And so in this case, if we're reading an integer, and let's say it looks like this, wherever it is you're reading from, 123 with a \n after it. This is what it would look like in a file. That's what it looks like for units. \n gives it that line feed at the end. So scanf will read the 1, and then it will read the 2, and then it will read the 3, and then it will read the \n and say, that's not part of any integer that I know how to read. Well, I'm done. I've read in 1, 2, 3. I'll return that as the integer. And it's done. Goes to the next line and does whatever else you want it to do. So that's why you don't have to tell it. There's a \n. So, any questions about scanf? So, just like with printf, this thing here has to correspond to the type of whatever it is you're reading here. Remember, with printf, we were a little floppy, and I let you print doubles with a %f. Scanf will not let you read doubles without using %ls. And we'll get into that in more detail eventually.
Is there such a thing as, I know you said that the students will make their own cheat sheet, but is there such a thing as a dictionary for students? Or else, maybe a dictionary is not the right word,
Reference
but...
card maybe?
Yeah, something.
I'm sure there's a cheat sheet for C syntax at least. Perhaps even a cheat sheet for all the C standard library stuff, which is what scanf and printf are all about.
Now, obviously, at some point,
I
I'm sure
can
it's a little
Google it.
unwieldy, but no, that's okay. I can Google it.
It's definitely one of those things. This review is everything I've taught you, but it's not all of C. I've tried to teach you a minimum subset of C that you can use to get stuff done with. And as we continue, I'll probably introduce a few more things as we go. But with this, you can do everything. Some a little less conveniently than if you use some other stuff, but you can still do that. So the reason I say that is that the cheat sheet will probably have twice to 3 times as much as what I'm showing you here. And it may be somewhat overwhelming.
Okay. Sure will. Okay.
Okay, so then there's the while statement, which allows you to repeat code. And so, just like the if, you start it with whatever the heck it's called, then parentheses, something that needs to be true, curly braces, and then something you want to do. So it's just like an if, except it says while. And the big difference between the if and the while is that when the if is done, it'll go to the next statement right after this and keep going. The while, it'll just keep doing it until whatever this is becomes false. And we did some examples where it never became false, and we just used Control-C to kill our programs. Then the next time, we came up with some fancier ways of dealing with that so that it would stop after a certain number of tries. So this is the example that we did where we have a condition, in this case, some counter being less than some number. And make sure that the counter has a value that makes this true, otherwise it'll never happen. Then make sure that the counter eventually makes this number 5 or more, and that way, for a while, it will stop, because that will now be false. So it's a lot of extra work to do these things, and to keep track of them, and to make sure that they're doing what you think they're doing. And I screw this up constantly, despite how simple it looks. It's always a pain in the neck. And one of the first things that most new students have trouble with is this initialization here. If you forget that, and you just declare n as an integer somewhere, in everyday C, it will have the value of whatever was in RAM where it put it there. I mean, it won't clear it to 0 or anything. So it'll just be some random number, which is very unlikely to be less than 5. And so the loop will never, ever execute. And that's a very, very common thing that a lot of beginners and experienced programmers do. Usually the experienced ones are just in too much of a rush and they forget. And, So anyway, initializing stuff so that the loop will actually happen the first time is key. And then making sure that it does stop is also key. And you can screw this up very easily. So sometimes, in a rush or something, you might forget it. You might put it outside the loop.
We put n+1 every single time. N+1. I always
Yeah.
put the plus instead of the equal.
Instead of the equals, yes. Thankfully, that doesn't compile, does it?
No, it gives you some
Yeah.
errors.
So, yeah, it's nice when at least it doesn't compile, so that it doesn't run and then totally confuse you. Because it doesn't run right.
Yeah.
But yeah. We will get into some of those issues as we go. So, just so you know, this one and the next one we'll finish up functions. And then I'm going to start talking about designing programs. How you make sure you do the stuff you need to do in the right order and put it all together to make something work. So far we've done very simple programs that do one thing. And the real programs that we want to write won't be just doing one thing. And so we need to make sure we do the right things in the right order to make that work. And we'll talk about all that in the coming weeks. And perhaps we may be doing it twice, given how many people may be missing classes. And twice is okay, I'm sure. Hammering at home is a good thing.
It's the hardest part of programming.
Yeah.
It's okay to go through it twice.
Yeah, definitely. I like to think of it as basically like if you're at home and you're making a cake and you're following a recipe step by step and you're making a cake. And that's what computer programming does. Except a little more detail. And we'll go into that. Okay, so functions. As you remember from the last time. Functions have a syntax that is quite similar to ifs and whiles. They have some kind of a name, a bunch of stuff inside parentheses, and a bunch of code inside of curly braces. And everything you've written so far starts with the word main, int main actually. So everything you've done so far has been writing one function called main. So this is a generalization of that, so you can write other functions that aren't called main that you can then call and do stuff. So just like with main, whatever this is, it actually returns a value. So like cosine. But cosine, getting the cosine of an angle, and you get a number back. You write that like this, some number equals cosine of theta, and so the function name is cosine, and it's returning a value to this, so that you actually, when you compute it, now this gets assigned the value that this thing computes. And so, in order to get it back there in C, you return it. And so the return type is a key thing in writing any function. In what we've done so far with main, the return type is int. And we've actually never returned anything from main. And main actually does return a value to Linux. It tells it whether it basically succeeded running it now. That's what it's meant for. And Linux can actually do something with that. You can decide to do something else in Linux if the program didn't work. So we actually write programs in Linux that use programs in C. But we're not going to go there, not yet anyway. But it's basic. It's the same basic idea. So everything in C is based on a bunch of functions. Printf and scanf are two functions that you've used already that somebody else wrote and made available to all the people that use C. So those are examples of functions. And they have names, they have return types. In this case, they don't return anything, which is a valid return type. And then they have arguments that are separated by these commas, like that control string and the names of the variables that you want to print are the names of the variables you want to read in. And so it fits exactly this idea of a function. And so when defining a function, you have to know exactly what you want to do before you write it. And so you have to have some idea as to what you're going to need in terms of variables, the values that you need to actually do whatever this computation is you want to do. And then you have to know what kind of thing you want to return. So, for example, getting the tax bracket, right? So in the main program, you did all these ifs to figure out which tax bracket you were in, and you calculated the tax rate. And then you applied that tax rate to what your salary was. So if you wanted to convert that to a function, you need to know what the salary of this person is, and you want to return back that tax rate. And then in here, you do all those ifs. So knowing what you're going to do, you can figure out what arguments you need and what you need to return in order to make these functions make sense. As you get used to it, you'll be able to think in terms of functions and design your programs without knowing exactly what's going on in here until you get to writing it. But you'll know exactly what you need in order to make it work. We'll get there. So that was any questions about functions? We're going to talk a little bit more, but any questions about this generic overview of functions? You know, it's basically too confusing to even formulate a question, right? Is that the
Kind of.
consensus?
Kind of. What is, explain what with type means.
Okay. So, yeah, I didn't go there. So, all these arguments that you send to this function and that it gets and then computes with, just like in your main program, everything has to be declared. And so, these arguments have names and they have types, just like when you declare a variable in your main program. Otherwise, this guy doesn't know what the type of that argument is. So, for example, with printf, you're sending it a string and some variable. So somehow, inside printf, it needs to know that this is a string. So perhaps it's called argument number 1 as the variable name. Somewhere right here, it has to say that that's a string, so that everything in here knows how to deal with that variable. Just like in main, you have to declare doubles, ints, character strings, everything has to have a type. So this is where you tell it what the type is of those variables that you're giving it. All the other variables that you need to make this thing work, you declare inside here just like you would main. But for the ones that you're sending, you declare up in here. So it's just getting used to where you're declaring it, really. And it's up there because you're making it clear to the compiler what it's supposed to do with anything with the data that gets sent to this function. It needs to know how to mess with those variables. Like for instance, let's say it was, let's say you had a function named add, and all you want to do is make it add 2 numbers. So you've got a function named add, and let's call the input variables A1 and B1 or something like that. And not much we know how to do. Now, somehow, we need to figure out where to, what types these things need to be. Let's just say for simplicity we're going to make these integers. So, whoops. So, let's make each one of these be an integer. So, add 2 integers will return back an integer. Inside here, we're going to return A1 plus B1. We're done. Now, when we use this, for our main program, we're going to declare, say, J and K as integers. We're going to assign J to 1, assign K to 3, and then we're going to printf sum is set B, and then we're going to say add J and K. Skipped over quite a bit here to make things more interesting. I'm not sure that was a good idea, but okay. So this will only work for integers. This had darn better be integers that we give it, or it's going to bark on us. It may bark when we compile, or it will bark when we run it. Either way, they have to be integers. So here, I made sure they were declared as integers. I assigned values to them, and then I called it here, add JK. And that expression, add JK, basically has the value J plus K when this is all said and done running. And then it gets printed right there. So I did %D, because that's for integers. And somewhere, before all this, I actually declared add the function like that. And we have to declare it, otherwise the compiler doesn't have a clue what the heck's going on. So just like we declare variables, we have to declare functions.
So now, as part of the big picture, you might call this function add from 20 different places in your program.
Right.
All times with different variables for different reasons.
Right. We could even call it with numbers if we want. We don't have to call it variables. As long as that value that we call it with is an integer, it'll work. So we could have defined this double. Make this double A, double B1, and return a double. And all these things had darn better be doubles. So you just put a decimal point there, it turns it into a double. And if we make this double, these decimal points, make this be an F, and of course change that. That'll all work, but only with doubles. So if we put integers in there, the thing's going to bark. This will work. Just passing an int in, that it should be a double. So I don't know if this helps or made things more painful, but this is so.
I don't either.
Something as simple as this, all it's doing is adding 2 numbers, but it needs to know what their types are. Otherwise, just like everything else we do, without the types, it's going to be garbage. So you have to give it the types. It won't let you use the file without the types. If you're still confused, keep asking questions. That's what today is all about.
Okay.
I know perhaps it's so confusing you can't figure out what questions to ask.
Well, I'm just thinking you went from int to double.
Yes.
So int is integer numbers, whereas
Yes.
double is real numbers.
Right.
So we just need to decide what kind of numbers we want.
That's right. You
Yeah.
have to know. You
So that's
have
why
to
you're
know.
saying you can make it, if you want an integer, do it integer. If you want double, do double.
Right.
Or
Whatever.
integer and real.
Yeah.
That's why
yeah.
you
It
put
can even
in
be a mix.
doubles over
But
integers.
whatever makes sense to you. And of course, it all depends on what it is you're doing. So you have to kind of know what you want to do before you can write this function.
The big difference between integer numbers and real numbers.
That would be my guess.
It's the
Like,
fractional part.
if I guess if I'm asking for salaries, that would be real numbers. So I want 50,000 to 60,000. Or it depends on how I perceive what
It all
$50,000
depends.
is.
I mean, if people don't get cents for their salaries, if they only get dollars, you could think of that as an integer. It all, and in some sense, it depends on how you want to use it as well. If you're going to use the salary and you're going to compare to real numbers, or you're going to divide it and get some fraction thereof, you might want to start with a real number, even if it is an integer. And it also depends on how you're reading it in. Say with this scanf thing, maybe you've got a table of numbers and they're all integers in the file that you're reading from to get this. Maybe it's a CSV or something, right? It's one of these spreadsheets that has salaries, but they're all integers. So, yeah, if you have to read it as an integer because it's an integer, but maybe you don't really want an integer. Maybe you want a real number so you can do real
No
number
sense.
stuff with it, even if it doesn't have sense. You want the 0.00. So, once you read it, you can convert it to a double. And luckily, you can just assign an integer to a double, and it'll make it a double, and it'll do the right thing. There's an example of that, too. So that's good. So you can read it as an int, convert it to a double, and then send it to your functions as a double, and do everything you want as a double. If that makes sense. These are things you actually have to spend a lot of time thinking about, either before or during the writing. Because if you make the wrong decision early on, it'll screw up something 2 days later as you're coding. Then you go all the way back and fix it, and then your code is doomed. Basically. You may get it to work sometimes, but you're asking for it. So thinking about types before you start writing is a big deal. And as part of that is getting these functions right. So you got to think about what you want to pass, what you want to send back, what types they need to be. Maybe you want to send back a whole bunch of other stuff too. We haven't gone there yet, but at the moment we have nice simple functions that always return a nice simple thing. This can get much more complicated. You know, probably doing that. But for now, types is a big deal. It always is in C, and you always got to be thinking about it, even if you're not doing functions. Because one of the, I can't remember if I told you, I think I might have told you, but if you've got int I equals 7, and j, double the, let's say we set b equals I divided by 2. b is not 3.5, as much as you would like it to be, because this is an int and this is an int, so C will divide them as integers, produce an integer result, and then assign that to B. And it's pathetic, and that's what it does. So if you want this to be 3.5, you'll get 3. So because of this and myriad of other issues like this, always got to be thinking about the types, and making sure that what you need to do is appropriate for what types you're using. So this is garbage. Not ever going to work, and it will drive you crazy until you remember this. And all you got to do is do this. If you just put that decimal point there, it's now an integer divided by a real number, and it will do this as a real divide, and then assign that real number to b, and you'll get 3.5.
You don't have to change the double B and
You don't have to change anything else.
Just that little dot.
Make this guy be a double, and it will do this operation.
Because you
It'll-
said double B.
This guy's double, so he can hold 3.5. But he doesn't care, and he is irrelevant to this computation. This computation runs without any knowledge of what the heck he is. It's just take that, do that division, get a number, then it looks to ask, okay, where do I put it? Okay, I put it in B. But it doesn't even think about that until it's got this put in B. So all it does is look at this, okay, integer, okay, look at this, double, okay. It's going to take this, it's going to actually convert it to a double, and then it's going to do the division, and then it's going to do the sign. So without the 2 being a double, we'll say, okay, that's an int, I'm going to do integer division. Produce an integer as a result. Really dumb, that's what C does. Some languages don't do this, but some languages, they're slower because they don't know what type things are, so they can figure it out as we go. C doesn't try to figure out what type things are as you go. It knows. Already knows it's I. Already knows it's an integer. So it's faster, which is why we use C.
Okay, so if you have an integer divided by a real number, it's gonna turn out as real numbers and numbers. But
Right.
what if you have a real number divided by
It'll work.
Make any difference?
It'll work fine.
Okay.
So if you have b equals 7, and you divide it by 2, an integer, it'll actually promote this integer to a real number before it does the division.
Okay.
So if anything in the division is a double, everything else in it gets converted to a double, and then it does the division. And it's basically a question of efficiency. And when it does the operations, it's got circuits inside the CPU that know how to do these things. But it knows how to do it with a double and a double. It knows how to do it with an int and an int. It doesn't know how to do it with an int and a double. So it has to make it fit the hardware. And so it converts as needed. More or less.
So you can say B divided by 2 and be done, or B divided by 2, period.
I
It would
always...
make, that period would be irrelevant because you've got a B in
It
front.
may be irrelevant, but I always, if I'm using constants, which these are, right? This is a constant as opposed to a variable. If I'm using constants in my code, I always try to make sure that the constant is the type that makes sense for it to be. So in this case, I wouldn't even do this actually. I'd do 0.5 times b, because that'll run 10 times faster. But that's another story. But I always make my constants be the type that I want it to be. I always think about what type everything is, variables and constants.
So if I know I want real numbers, I'm gonna put 2
You're gonna put 2
within
period.
that, no matter
Even
what.
if you don't need it.
No matter what, just so you
Yeah,
get used to
even if you don't need it,
writing.
you know that it's gonna be a real number, you make it a real number. Otherwise, you're just asking for trouble. So types is a big deal. It's why I spent so much time on it early on. Types is a really, really big deal. And a lot of these fancy, newer languages, they figure out the types for you as they go. That's a major hunk of code, figuring that out every time you do something. So those things are very slow. As long as you know what you're doing, you give it the types, it's fast. So what time?
12:57.
Ooh, okay. I figured I would talk most of the time for this one. So yeah, there's the example that we did last time. So we want to figure out what the price of bananas is. In order to figure that out, we need to know how many bananas there are. We know that that's an integer, and we know that the price is dollars and cents, so we want to return the double. Inside here, we're going to calculate the price of the bananas, so we're going to declare this variable in here so we can use it. We really can't use variables that we don't declare. Even if this is declared in main, this function knows nothing about main. Absolutely nothing. It's an entity all on its own. So no matter what you did in main, it's irrelevant to what you do here. So you know, declare that if you need it, then you can use it, sign it, return it, and away you go. Does that make sense?
I'm just looking to put that to fill out all the numbers and make it double. But there's always
Yeah,
0.25,
you'll notice.
number of bananas 50,
I mean,
you don't need it
that's an
there,
integer.
so it's already
And
a double.
that's an integer.
Right.
We're comparing integers. If you compare integers with real numbers, the same thing happens that happens with this division thing. It has to convert. So don't make it convert because it's going to screw it up. You do what it needs to be so it doesn't have to.
Well, you know, on the safe side, because we always do declare variables, why don't we declare a number of bananas?
We declare it here.
Yeah, but it's not in the function.
It's not inside the brackets. It's a special thing for functions. So the stuff that you are sending to the function gets declared inside these parens because it's an argument to your function. And it's as if you declared it in here, but it's special. So that it's out here, but it's usable inside here. So inside here knows about these declarations up here in the paren.
Did
I
you
think
mean-
that's what's going to confuse
That's
us.
crazy.
Did you mean,
Yeah.
and Shannon, was your question then, why isn't it in front of, in the parentheses, no bananas? As an int as well?
Yeah, like inside the actual function,
Yeah.
because you said anything declared in main doesn't count, and you
Right,
want to redeclare it, so I was
Right.
confused why we declare price bananas but not numbers.
Right.
Gotcha.
So this does not have to be repeated here, otherwise you're likely to screw it up. That's what they basically. So it's nice. It figures that if it's a function and you're passing this, that you also want to use it in here. So it's kind of like this is in here and the compiler does it for you.
Yeah, the piece that is confusing though is that you do have double price
Yeah,
bananas
see,
as
that's why I'm
opposed to
wondering,
just
because then I'll be like,
price
oh, that's
banana.
right there.
That's right. This and this are different names, aren't they? And that's on purpose as well. If I cannot use a function name as a variable name inside that function or I'm asking for trouble. So I had to call this something a little bit different.
Okay.
And
That's
that's
why
another
you
thing
had your name it
that,
as double the first time, but not the second.
well,
No?
there's only a first.
No,
Price
no,
of bananas is only one.
no, the price of bananas.
So, I called it a double there. Did I call it a double anywhere else?
No.
I mean, it only needs it once, just like your main only needs it once. And then we use it. In this case, 3 times, but. Okay. And I always do this, because otherwise I don't know what the heck curly brace is ending. After a while, you get so many curly braces,
You don't know.
you go crazy. Ideally, I'd have it end it over here, but I didn't do it. But okay, that's it for today.
And what, that // end function,
End function.
that's only for your,
That's
just
a
like your
comment.
side note? Okay.
That's just comment.
It doesn't have anything.
not
to go with
necessary.
it.
Comments can be anything you want. They don't have to be there at all. It's purely
Just to help you
my way of
visualize
doing
it.
things.
Thank
To
you.
help you and the next person who has to support your code.
Thank
Which,
you.
Which is tough.
That was helpful to go through that.
Yeah.
So far removed from it.
Yeah, think you can later when you're
Sure thing.
actually using them.
Yeah, that's what we're talking about for you.
No, using it often and.
Thank you, Leila.
Yeah,
Have a good day.
you too.
Thanks, Liz.
Okay, I didn't even do anything. You were here. See you next week, Leland.
Yeah, you bet. No, I appreciate your